So we have an expert panel today to comment on this. I'm going to introduce each panelist very briefly with their company and their name. Let each one of them speak for a couple of minutes, and then we'll have a short discussion. First, we have David Durham, is the president of Energy Systems at Westinghouse Electric Company on my immediate left. Then we have Jeremy Harrell, is the chief strategy officer of Clearpath. Michelle Brechtelsbauer is the chief strategy officer of Last Energy. Lamine Selmane is the field director in Dell's energy practice, focusing on the Middle East, Africa, Turkey, and France. And then last, but certainly not least, Costa Samaras is the principal assistant director of energy at the White House Office of Science and Technology Policy. And we're always very pleased when the White House can join us for sure. So thank you so much. Go ahead.
All right, good morning everyone. Happy to be here. I think what's really amazing as we look back over the last 30 plus years of my career, which has been almost all nuclear. I'm with Westinghouse. We've been in this business for 70 something years. But there are so many startup companies, so many new technologies being looked at. And the debate now isn't just about how many large reactors are going to be built, like our AP1000, but it's now about SMRs. It's now about SMRs, light water reactor SMRs, as well as Gen 4 reactors and micro reactors, each of whom have very different applications, very different timelines to market, very different levelized cost of electricity, quite frankly. But it's just exciting. I think I heard that there are 56 different technologies being developed right now. Not to put a bummer on it, but I don't think all 56 are going to make it to market, but I bet you 5 to 10 of them will. And so it's a very exciting time. And it's not just old nuclear utilities, it's governments, it's newcomer nations like Poland, where we just signed a contract for 3 units. It's companies. Look, we have Dow on the panel. It's companies looking to go nuclear themselves. So it's just a very exciting time to be in the market.
And before I pass it on to Jeremy, David, just one word: is Westinghouse immediately involved in investing in these smaller companies in any way?
We're not involved in investing in companies. We're involved in investing in our own technology.
Your own technology.
So we have one of each. We're the only one that has more than one technology.
Okay, just wanted to be clear. Okay, thanks.
Large, Gen 4, light water SMR, and micro.
And micro. Thank you.
Excellent. Well, good morning, everybody. My name is Jeremy Harrell, and I'm very excited to be here in what is, I think, a landmark COP and seeing true momentum for new nuclear across the globe. Clearpath, for those of you who may not be familiar, a DC-based advocacy clean energy organization that's mission is to focus on technological innovation that will reduce and remove global emissions. And so our mission is climate action, and nuclear is a huge piece of that for a variety of reasons. And it's the immense applications and role that nuclear can play in decarbonizing the global economy. In addition to my role at Clearpath, I serve as the chair of the board of directors of the U.S. Nuclear Industry Council, which is a U.S. trade association focused on new technology and services and promoting those globally. And we at Clearpath have gotten involved more directly in the industry because of the immense upside that this technology has to scale up and help the globe meet its climate goals. In fact, we more or less have concluded that it's a technology that's a need to have, not a nice to have, if we're going to reach our climate goals on a climate relevant time frame. Near impossible to reach net zero by 2050 without an immense scale up of global nuclear power, which is why I think, for example, the 22 nation agreement that was announced earlier this week to 3x global nuclear capacity is a huge opportunity. And so I'm excited to join my colleagues here on the stage to talk more about what's happening in the U.S. and the immense momentum across the globe.
Michelle, what is Last Energy doing?
Hi, everyone. My name is Michelle Brechtelsbauer. I work with Last Energy. We are a micro-modular nuclear development company. So we build really small nuclear power plants to help industry decarbonize. We have a pretty unique business model in this space because our units are so small. We've essentially productized and standardized nuclear power. So instead of building, stick-built plants that are custom for every single project, we're moving towards factory fabrication and true scalability and through modularization through our technology. And then we're offering power to our customers who are industrial energy users through power purchase agreements. So we're taking the business model that you've seen pioneered by the renewables sector and bringing that to the nuclear industry so that we can truly scale up nuclear power where it's needed most, which is not just the grid. It's distributed around the world for small communities, for industry, and really truly trying to kind of bring this into the private sector hands and let the private sector lead on nuclear energy, including through private financing as well. I'm really excited to be here at COP. This is Last Energy's first time joining COP. Our mission was actually founded first on climate change, and we've expanded that to ensuring that all of humanity can flourish through clean energy.
Lamine, tell us how Dell is using nuclear energy to power your industrial operations.
Yeah, good morning, everyone. Really excited and happy to be here, part of this panel with my colleagues. So my name is Lamine Selmane, so I'm part of the Dell Global Energy Practice. So it's really a dedicated team of subject matter experts within Dell with the mandates to build digital solutions for the energy sector. And the solutions are around three main areas: how we can help this sector secure or achieve energy security, how we can also help these companies decarbonize quickly, and how we can also support the energy transition. So in terms of nuclear power, it's all about how we can help our customers in the digital industry to reduce the carbon footprint of their IT infrastructure. So especially with the proliferation of AI and blockchain and cloud services, how we can make sure we support the effort of these companies throughout their digitalization journey to reduce their Scope 1 emissions and even their Scope 3 emissions. So this is what we do day in, day out. And I'm pleased to be here to represent the perspective of this industry, the digital industry, and how we can better integrate the nuclear energy as a clean energy to support this energy transition.
So I need to point out that we invited a number of the large digital producers, if you will, the cloud producers, and they've all said to me that they are furiously working on developing their policies and their strategies for this right now. They are, as you know, with the clouds that are being created around the world, some of the largest users of electricity for the future.
Yeah.
And those policies and strategies really need to hit the road and get going here. So we're looking forward to hearing more from your industry on this.
Definitely, absolutely.
But in the meantime, Costas, tell us what you're doing from the standpoint of Office of Science and Technology, please.
Well, thank you so much. Welcome, everyone. It's an honor to be here. Really excited on this momentous COP. We at the White House Office of Science and Technology Policy provide science and technology advice to the President and the White House on technologies that advance the health, well-being, and security of all Americans. And so in the energy sector, let's look at the facts. The modeling for decarbonization in the electricity sector says we need at least 500 plus gigawatts of clean, firm power to decarbonize the electricity sector by 2050. Nuclear can play a critical role in providing some of this clean, firm power. And that's why at COP there is an announcement, which includes the United States, that was referred to by Jeremy, to triple nuclear power by 2050. But there's also an announcement from the United States to join with Canada, Japan, France, and the United Kingdom to increase the security of our supply chain and make investments in fuel to make sure that we're getting projects built and projects online. And then lastly, the President made an ambitious commitment to decarbonizing the entire economy, but no later than 2050. Nuclear is a Swiss Army knife in that decarbonization. It can decarbonize the electricity sector. It can decarbonize the industrial sector. It can make clean hydrogen. It can make clean water. There's the future of nuclear power and clean energy innovation is bright in the United States and around the world, and looking forward to our discussion here today.
Thank you. Michelle, small modular reactors are the innovative game changer, if you will, the new technology that everyone's been talking about the last number of years. Can you just give us a few more words on how they differ from traditional things, like what Westinghouse has done throughout its wonderful history and storied past? What is what your company is doing in this regard so different and so innovative?
Yeah, so Last Energy, we consider ourselves micro at nuclear power plants. So we built a 20 megawatt power plant that We do use like the standard reactor technology, proven reactor technology, pressurized water reactor. But what we're able to do at that micro scale is look at the rest of the balance of plant and focus on innovation there that allows us to actually build these much quicker and focus on the real true problems that we've seen historically with nuclear project development, which are cost and schedule. So if we can standardize the power plant in its entirety so that it can be factory fabricated, manufactured in a controlled environment, and then the same thing built every single time, that's really the path that we see as being the most critical to addressing those issues of cost overruns that we see with most large projects, as well as the time it takes to build them. So as I said, we're at the 20 megawatt scale. There are SMRs, the traditional kind of buzzword in this space, small modular reactors. I think you can speak more to it, but these are traditionally up to maybe 100 to 300 megawatts as well. And then, of course, the large reactors, the gigawatt scale ones that we see, really primarily supplying electricity to the grid and helping decarbonize grids of a lot of the major nations that have really committed to decarbonization.
I worked from the very beginning with the UAE on its 123 agreement and its nuclear program here with ENIC and the Westinghouse technology, the South Korean technology. What's different from a safety standpoint? Are these smaller reactors easier to secure and make safe, or is it the same things that we have to worry about with the big reactors?
It is very different. At the smaller scale, you can do things that you wouldn't be able to do in terms of design at the large scale, right? So you have obviously a smaller source term, you have less fuel in the reactor, but it's also physically smaller. So you can encase it with more safety materials, and you can build, in our design, we bury our reactor underground. You can do things like that you wouldn't be able to do with the much, much larger power plants. And then, of course, in terms of security footprint as well, there is a reduction there given the smaller source term and potential risk. But I think that the main thing is there's really a benefit to the environmental footprint of micro reactors as well as small modular reactors. And that's not just in terms of the physical space, right? So if we're working on integrating a micro reactor for an industrial customer next to their facility, we can actually build a private wire to their facility because we use air cooling in our plant, so we actually don't have to be near a body of water. And that's really critical for our customers because it also enables them to have those cost savings of taking out that grid connection, which is often, can save them up to 50% sometimes, depending on the country where we're located. So those are critical things. But then even in terms of the regulatory timelines, right? Smaller footprint means lighter regulatory reviews from the environmental permitting perspective and all of those areas. So we're taking that into account through the design.
Excellent. That sounds really, really fascinating. Costas, the U.S. and the UAE signed an agreement recently on PACE with Romania. Talk to us a little bit about that and what the future of this is under PACE from the standpoint of the U.S. government, UAE government working together to promote more projects like this.
So this is a global agreement. It's the Partnership to Accelerate Clean Energy, and it provides up to $100 billion of new investment to catalyze that investment for clean energy projects across several pillars around the world. One very important one is clean nuclear power. And what it's going to help realize is get 100 gigawatts of clean power built over the next 15 years in a way that is accelerating the market, bringing the private industry to get new nuclear power built in this decade. And so we're very, very excited about this partnership with the United Arab Emirates, but really it's a global partnership to catalyze all the investment that is hungry for these types of exciting projects, both here and around the world.
Okay, thank you. David, a lot of discussion at this COP, and I've been involved in a number of panels on sustainable green finance for the future on some of these projects. Talk to us a little bit about the economic trade-offs, some of the work that you do on some of your projects in adapting nuclear power, the financial pathways for how we help countries and other localities in this regard.
Well, I think that there are already existing mechanisms, particularly with the U.S. government, from our perspective, that can help make new nuclear reality with all over the world. It's just a question of streamlining the processes and making sure that the financial commitment is there from the Congress. I mean, XM, DFC, they have the tools to help make this a reality. And whether we're talking about large reactors or SMRs. So I think the tools are there, but they haven't really been flexed, and they need to be.
But what about, how are you working with these organizations to make them economically more feasible as a company?
Well, I don't know how to answer that question.
That's okay.
Yeah, we're working hand in glove with XM and DFC as we pursue opportunities. But at the end of the day, they've got to make the decision on financing.
On the financing. And I know that the various development banks are here at COP this time in a way that they've never been together before. They're working together to create an association of associations, if you will. So there's going to be many, many more players to work with on the financing of these projects.
Some of whom have to change prior policies in order to participate in the nuclear industry.
In the nuclear industry.
Yeah.
And do you think that could happen?
I hope it happens. I'm not a good
Okay.
prognosticator.
Jeremy, tell us a little bit about the versatility of nuclear energy from your perspective and the impacts of potential end-use applications. And what do you see as the biggest impact in terms of industry adoption?
Yeah, I think it's exactly why we are here at COP and we're seeing such an increased focus on nuclear power as a whole. There is an immense demand from a wide range of industrial users for heat, for steam, and for electricity. Just to give you an example, the four building blocks of the global economy, ammonia, cement, steel, plastics, all need high temperature heat, and we want clean heat if that's a sustainable future. Not to mention the immense need we're going to have for baseload electricity as we increase data centers, as AI takes off in the global economy. And so it really is a paradigm where the global economy is demanding what nuclear can bring to the table. And so I think it's a really exciting moment, and I think it's why you're seeing governments and industry come together here on what is a really exciting commitment to 3x global capacity to meet our goals.
Lamine, David just mentioned AI. Talk to us a little bit about the role that AI is going to play in the future in this regard, please.
Yeah, well, it is estimated that in 2020, just to give you some context, in 2020, like 3 years ago, it was estimated that data centers accounted for around 2% of the global energy demand. But with the rapid rise of these data-hungry services like AI, particularly generative AI, with all the excitement around generative AI and the required banks of GPUs and chips, cloud computing as well, as I said, Bitcoin mining. So this figure is definitely expected to rise exponentially in the coming several years. So in fact, some estimates for 2030, the energy consumption of the data centers will account for more than 20% of the energy consumption. So this rapid expansion of data center capacity will definitely strain the capacity of the local grid operators to provide any kind of energy, let alone clean energy, which is the requirement today, which is basically more and more requested by the data center users, again, to achieve their climate goals. So this is where nuclear energy is really a great opportunity for the data center sector with a steady, dependable base load that doesn't rely on the sun shining or the wind blowing, with also this the possibility to go for long-term power purchase agreements to provide this kind of commercial assurance. The density is another advantage also for this for the data center sector. So it doesn't take as much space to provide a massive volume of power. And we talked about SMR. This is more relevant for SMR. So if you think about maybe a typical 200K square feet data center is not a good candidate for SMR, but if you think about a data center campus with 100 of megawatt capacity, can be the sweet spot for SMR. And for the smaller data centers, a 10 megawatt micro reactor can be a perfect fit in this case. So there's really here an opportunity with the advance of AI, as I said, cloud services and Bitcoin for the digital sector, for cross-sector collaboration between the data center sector and the nuclear sector to have a co-located facilities where you have nuclear generation, distributed nuclear generation in form of SMR or micro reactors co-located with a data center campus or data center facility.
Excellent, David. And I'm going to come back to Michelle on that point.
Okay. Just just maybe to add to that a little bit, just to share. I mean, if you look at our eVinci microreactor, 5 megawatts, it'll be ready for application.
5
in 20,
megawatts.
5 megawatts.
Wow.
It'll be ready for application in 2027. We've signed an agreement, not disclosed yet, but it will be soon, with a major data center company, one of the biggest in the world. We hope to be talking to others and look forward to that. But, you know, their question is, can't you do it faster? They want it now, and the demand is tremendous. A lot of data centers are far less than the SMR side, but now they're starting to ask about SMR because, like you said, there are some data centers out there that are 100, 200 megawatts, and that's perfect for an SMR. So we're seeing huge interest.
Absolutely, yeah.
Michelle, I asked you before we started a little bit about an SMR powering a city, but talk to us about the challenges and the opportunities of integrating the SMR directly into a manufacturing, into a company's operations, just for those purposes, just for their needs.
Well, I think first and foremost, I like how you frame it as into a company's operations, because that's what our customers care about, is them, you know, their operations not being interrupted, and having that secure, reliable, consistent baseload power source that they need, and not having to change their business model in order to get that, right? A pulp and paper manufacturer does not want to operate a power plant. They just want to create their products. And so that's really the key thing that I think that the nuclear industry and that Last Energy can provide those customers, is the assurance that they're going to have the power that they need, and they can just get on with it.
So they won't run the plant.
No.
You will.
Yes.
But it'll be right there, very close
Exactly.
to them, and you will be part of their daily operations.
Yeah, one of the biggest pain points that we've seen, especially in the United Kingdom, is the time frame that it takes to get a grid connection. We're speaking to customers who are looking at, 2035, 2036 before they're even able to get grid connections. They're so constrained, and saying we need it now. I mean, really, they truly do. In order for them to not only work on their current operations, but have future growth plans, they have to have these sources of power. So we can build our facilities right next to theirs, and do a private wire directly for electricity. We can also provide them heat on their campuses, and then critically, our power plants are 20 megawatts, but we can scale up to meet the demand that they have along with their growth trajectories, right? So if we're working with a customer who right now needs 100 megawatts, we'll build 5 of our power plants, and then as they need additional power, we can just build redundant capacity in a row right there.
Excellent. Costas, what is the U.S. government doing from a policy regulatory perspective to help enable and push this process along with private industry and nuclear power?
Well, Danny, if you look at just the announcements that the U.S. helped lead here at COP, I mentioned the tripling of nuclear power. There's also the Export-Import Bank of the United States is working with the State Department to outline new financing opportunities for the high demand of U.S. SMR technologies for export around the world. But in addition, the tripling of renewables, the doubling of energy efficiency, all of this ties back to the opportunities domestically in the historic bipartisan infrastructure law and Inflation Reduction Act. And I'm going to go through this super quick. I'm not going to read the whole bill, I promise. But for nuclear power,
It's this thick, isn't it?
well, it's the most ambitious climate investment in history. And let me tell you about what's in there for nuclear. First, we're going to do advanced R&D and demonstration with advanced demonstration of large reactors. That's $2.5 billion. Second, we're going to keep existing nuclear power plants online through the Civil Nuclear Credit Program. Third, we're going to pull new nuclear technology to market by investing in production tax credits and investment tax credits. And then fourth, the Department of Energy Loan Program Office is going to bridge the gap between commercial finance and bankability. And so when you add all those things up, the Department of Energy's analysis showed that nearly all of our existing nuclear power plants will remain online, and that new nuclear power is positioned for growth in the United States and around the world.
Go ahead, Jeremy. You had a comment.
Yeah, I just wanted to add there and underscore, because it's a question that I'm already getting across the pavilion here today, is what's the political sustainability of the policies that Costas just mentioned? And no single technology in the United States has gotten the public policy support that nuclear has over the last 5 years. We've seen immense support from Congress, billions of dollars of financial assistance for cost shares of demonstrations technologies, brand new tax incentive, over a decade worth of leeway to catalyze the deployment of new technologies, investments in the fuel cycle, legislation directing the regulator to modernize and ultimately drive the technology forward based off the new dynamics of these next technologies. So the globe should know that the U.S. is in this for the long run and have confidence that U.S. technologies are here to serve the global market.
So, ladies and gentlemen, I always on all my panels ask panelists to do a little bit of crystal balling. If we're at COP33 5 years from now, what are we going to be talking about? What are the issues going to be? What are the highlights going to be? What are the new developments going to be? Just from your perspective, I'm going to start with David, just because Westinghouse is on the cutting edge. What?
I want to make sure I had the right time frame.
Yeah.
Sorry.
No. I was even going to give you a break because I was going to say, because you are on the cutting edge of some new technologies. What's Westinghouse doing now? And then looking into the future a little bit with that.
If I had to predict the future for Westinghouse, if you look at where we are now with AP1000, we have 5 operating, we're nth of a kind, we have 6 more under construction, we'll have a 6th one operating in a few months. So truly nth of a kind. In our pipeline in the next 10 years are 30 more AP1000s, wow. 6 of which are under contract today. And most of the others are, I won't say they're in the bank, but they are very close to being in the bank.
Any other innovative new technologies we should be thinking about?
Our AP1000, which is...
And your stockholders, I know they care.
Well, they certainly loved yesterday's announcement of the tripling. I think our value just tripled. Our AP300, our SMR, it's a 340 megawatt miniature AP1000. 0 first-of-a-kind technology, same exact design, same exact safety basis. Most of the equipment is the same exact equipment. So like a reactor coolant pump, we know exactly what it costs. No other SMR vendor could say that. They haven't even produced any of their equipment yet. And so from that standpoint, 10 years from now, I could see a dozen, if not more, AP300 projects underway. Our Vinci reactor will be to market in 27-28 timeframe. We've already signed our first customer, Saskatchewan Research Council up in Canada for the Alpha unit. So I envision that will be in the dozens of, because it's the same kind of machine. It's manufactured 100% in a factory and it's transported to site on 3 trucks, and it takes 30 days to hook it up.
Excellent. Go ahead.
Sure. I think by the 2033 range, we're going to be talking about the next wave of nuclear that is transforming the global economy as a whole.
So what is that?
And the U.S. taking a global leadership role in bringing those technologies to the market. I think, as David mentioned, of the many entrepreneurs that are out there, we're going to see a natural down select, but I think we're going to see a handful of designs that are deployed across the globe, and this is not just Eastern Europe, not just in the U.S., in Africa as well, with a wide variety of applications. Technologies partnering with data centers, with chemical producers, with cement producers, and folks like Nucor, for example, the largest steel producer in the United States. I think we're going to be looking at what is going to be a takeoff, and we're going to be having a conversation not about the tens of projects that we successfully have built at that time point, but the hundreds that we're going to be building over the next decade.
Will there be more nuclear for the global South? Will there be for those that we worry that are going to be left behind? Will there be more investment in nuclear in those places?
100%, and I think it's actually an essential to adjust energy transformation in those type of economies, and I think it's why the United States and the allies that signed the 3X agreement earlier this week have committed to driving forward and finding ways to de-risk and finance those projects in the global South.
Michelle.
So 2033, that's going to be, I think a really critical time to see if we can look back and actually ensure that we got there. I'm hoping that we far exceed everything that's already been said, and what I will say. Right now, Last Energy has...
I said COP 33, meaning 5 years from now.
5 years.
So
okay.
I didn't mean to put you 10 years out. I'm
okay.
sorry.
Well,
I'm sorry.
I'll adjust
but
my
you can do 5 or 10 years, whatever works.
Well, right now we have 52 power plants in our pipeline. Across the 4 countries where Last Energy is operating: the United Kingdom, Poland, Romania, and the Netherlands. So in 5 years, I certainly expect we'll have a few of those first ones coming online. We're looking at 2026 most likely for the United Kingdom. So at that point, we're going to be moving from first-of-a-kind projects to really transitioning not only our business, but our kind of overall global footprint to that high-throughput manufacturing model that I described. Of course, our first projects will be more bespoke, figuring things out, but by 5 years from now, that's when we're really going to start ramping up in terms of that scalability factor.
And any new or innovative technologies that you might want to highlight that you think we'll be seeing 5 years from now?
I mean, I think, at that time, Last Energy hopefully will have been able to prove that you can build a nuclear power plant for less than $100 million using only private finance and no government subsidy whatsoever.
Congratulations. We'll hold you to that. And 5 years from now, we'll be here to celebrate that, okay?
Yes.
Go ahead, sir.
Well, what I personally love to see in the coming 3 to 5 years is more synergy between the tech sector and the nuclear energy sector.
It's imperative.
It is an imperative, absolutely. The nuclear sector will build the capacity to provide this distributed, co-located, clean energy for data center and data center campuses. But on the other way as well, how the tech center will also power the nuclear energy with AI capabilities. For example, supporting the lifetime cost of this type of energy. There is a number of promising AI use cases that will just help the nuclear energy reduce their downtime, reduce their or improve their efficiency. For example, predictive maintenance, things like visual AI as well to spot equipment damage and HSE non-compliance, and even some material leaks, and even using generative AI to create this collaborative digital workspace for the engineers to use just natural language in order to search for engineering documents or the engineering information, interrogate process data, generate some turnaround plans as well. And even today, as we speak, there are some major energy companies working with Dell, building high-performance computing capacity to do R&D for nuclear fusion. If we didn't talk much about nuclear fusion as another promising technology. So we're already supporting some of the tech companies, some of the energy companies in this particular sector. The other aspect is also how the tech sector can support and work with the nuclear industry to prioritize cybersecurity as within a holistic risk management approach. So the experience that the tech sector has in terms of managing some threats, some cyber threats like ransomware, like IP theft as well, especially if we talk about SMR, the IP on SMR is now a target for foreign states who wants to build their domestic capacities, and also the supply chain risk as well with the distributed nature of manufacturing and supply chain, especially for the SMR case. So how we can help and support this sector in terms of better awareness, in terms of sector-wide cyber incident response, in terms of vulnerability assessment. So this kind of synergy that I really look forward in the next 3 to 5 years.
You're just going to promise me one thing, that AI is going to be our friend in 5 years and not our enemy.
Yeah.
Promise?
That's another topic for
Okay.
another panel discussion.
Costas, if you want to take off your official government hat and just as a chief scientist from the National Academy of Sciences, tell us 5 years from now what you think we'll all be facing. Happy to hear it. However you want to address the question.
Well, my government hat's going to stay on
Okay.
because I'm excited about the future, but I'm also excited about the present.
Okay.
And here's why. Already, since the beginning of the Biden-Harris administration, there's been $133 billion announced in private clean energy investment in clean power plants in the United States, and that's out of more than $500 billion in clean energy manufacturing and clean and battery and electric vehicle supply chains. The clean energy manufacturing renaissance and supply chain is already growth is already happening in the United States. 5 years from now, we're going to be in the tailwind of an exciting growth in all clean energy innovation and manufacturing in the United States and around the world. And I'm very, very excited about the possibilities that the Bipartisan Infrastructure Law and the Inflation Reduction Act enable for advanced nuclear power. And I'll lastly say is that the Biden-Harris administration launched the Net Zero Game Changers Initiative last year, and advanced nuclear is very prominent in part of that Net Zero Game Changers Initiative. And what that basically means is we don't have to wait for the technologies of the future, but we're always going to be investing and keep our eye on the horizon while we're deploying the exciting stuff that we have today.
That's fantastic. And in this part of the world, they have a saying, it's called Inshallah. meaning God willing, all of this is going to happen. So ladies and gentlemen, please, a warm round of applause for our panelists here today on a really exciting topic.